Hello everyone. In this video we are going to look at differentiation of inverse trigonometrical functions. In the previous video we just looked at the introduction and covering the all methods of differentiation. Now let us have a look at differentiating the inverse trigonometrical functions. We shall answer the questions here. Find the derivative of the following sine inverse of x. Now, for sine inverse of x, we shall say let y is equal to sine inverse of x. And from trigonometry, we have that this one will be our sine of y will be equal to x. And now, since we're aiming at getting dy dx, we shall say differentiate both sides, mean that we are going to get cos y dy dx, which is equal to, on the right hand side we shall get 1, and then at this point we can have dy dx is equal to 1 out of cos x. Now at this point, sorry, it is cos y. Now at this point we need to look for cos y in terms of x, but we know our properties in trigonometry. From cos squared y plus sine squared y is equal to 1, we can have that cos y is equal to the square root of 1 minus sine squared y. And now we know our sine x is the same as sine y is equal to the same as x, and then at this point we shall get cos y is equal to 1 minus x squared. Then by substituting now in the previous question, by substituting this in this, we shall get dy dx will be the same as 1 out of 1 minus x squared. But what is our y? We shall get dy dx of sine inverse of x is equal to 1 out of the square root of 1 minus x squared. Okay. Now let us go to the next question and see. We shall have now the next one is cos inverse see, we shall say that y is equal to cos inverse of x, and then from this point we shall have cos y will be the same as x, like what we have done in the previous question, mean that we shall say differentiate both sides. Then we shall get negative sine y, then dy dx will be equal to 1, and then from this one we can get our dy dx will be equal to 1 out of sine y, but because of a minus we can put the negative up. But we have a property that we are using in the previous question, that means that at this point we shall have but sine y can be written in the form of cos squared y, mean that from here we shall have it as 1 minus cos y is the same as x squared, and then have it like that, implying that what will be our solution? We shall have that our dy dx will be the same as dx of what is the function? The function is cos inverse of x will be equal to minus 1 divided by 1 minus x squared. So that is it. I believe now at this point even you can be able to solve also the third one. You can first take a whole and you solve it aside, then come check on the answer. Okay. Okay. Let us also solve it. Okay. Also, let us say let y is equal to tan inverse of x. It means that at this point we are going to get our tan of y will be equaling to x. Now from this, we know what we did in the previous questions, in that we shall just differentiate both sides. In that at this point we shall get, if we differentiate tan, we get what? We get sec squared. In that at this point we shall get sec squared y, but we are differentiating with respect to x. In that that's why we shall put here dy dx is equal to 1. And then at this point we get also dy dx is equal to 1 out of sec squared y. But now for tan, it is different because the property we are using at first is different from the one we are going to use. Now we are going to apply the property that, now let us apply this property, meaning that where there is sec squared y, we shall put that one. And that at this point we shall get dy dx will be equaling to 1 out of 1 plus tan squared y. But of course we know what tan is. Tan is x. And then at this point we get dy dx will be equaling to 1 out of 1 plus tan squared, that it will be x squared. This is why we always see when you integrate tan of inverse, we just get 1 out of 1 plus x squared. And now also for the derivative, that's the same relationship. By differentiating tan inverse, we get 1 out of 1 plus x squared. And then by integrating 1 over 1 plus x squared, we always get tan inverse of x. We shall always look at it when we reach on that part of integration. And now I just want you to also have a recap on the next part that we can look at. But let me just give you a highlight and you can be revising before you watch the video. In the next video we are going to look at how to solve the questions of the form cos fx and cos inverse of fx, sin fx and sin inverse of fx, and then also for tan, of course, tan fx and tan inverse of fx. In case you have got a question or the part that you have covered, you can just comment with the question or hit me directly on the channel that I have put in the link for WhatsApp, so that you can just be able to solve and give you the feedback. This one, just take it as an exercise. Thank you for watching.